This is a classic physics problem where hopefully you are never the victim. A speed trap is set up with two pressure-activated strips placed across a highway, 103.7 meters apart. A car is speeding along at 33.7 meters, while the speed limit is only 28.8 meters per second. At the instant the car activates the first strip, the driver begins slowing down. Have you guys ever done this before where you're driving, you see it in your neighborhood, and the cops have this like radar gun up, and it says, your speed? And it's like, oops, 39, and the speed limit's 25. You know what I'm talking about? So one of my neighbors complained, actually, in our neighborhood that too many people were speeding. So they actually set up one of these things where not only is there that radar, these two strips. And what they do is they collect a lot of data. And if a lot of people are speeding, they add a stop sign. So what I do is every time I see one of those in my neighborhood, I drive really, really slow. Like I slow down to like 5 miles an hour. So I try to drop the average so they don't add like 6 stop signs, okay? But anyhow, what minimum deceleration is needed in order that the average speed, that was a tricky part that most people miss. So I put that in bold. Within the limit by the time the car crosses the second marker. So step 1, anytime we want to break down a complex problem, what's their first step is what? Visualize the situation, okay? A lot of people think like I'm just trying to annoy you with the sketch. I'm actually not. I'm trying to make your life easier, okay? If you can picture what's going on, that helps you figure out the known and unknowns. And then the rest is just basic algebra. You guys are good at algebra. You're good at solving for x. That's all they do in the math department. They hide x from you for 4 years, and eventually you guys can just find x. Like, oh, look, it's in algebra. Oh, no, it's in trig. It's in calc. There you go. So you can find x. The hard part is the physics. Let's do it. Here's a sketch. Here's you driving along in your neighborhood way too fast. Slow down. There's little kids playing, right? Don't kill anybody, eh? And then, in order to catch the speeders, there are 2 pressure-activated strips. Have you seen that before? It's like a little like rubber kind of hose you drive over. You know what I'm talking about? Okay? And usually there's a sensor that collects data. If too many people speed, they're going to add a stop sign then to that neighborhood there, which sometimes is not a bad idea. But sometimes it's just annoying if, they overdo it there. So that's what traffic engineers do, okay? So let's look at our numbers. The first number is 103.7 meters there. So right away, let's start breaking down step 2, but label it on our diagram. What's 103.7 meters? A hint is the units give it away. Meters is a measure of... Yeah, it's early, right? Brain no worky. What's meters? It's a measure of distance. How do you say distance in fancy physics words? Thank you. It's our delta x, okay? So let's just go ahead and draw this in here so we can visualize it, okay? Next, the car is driving at 33.7 meters per second. So what's that? That's the speed you're going when you first cross the first strip. So how do you say your speed at the start? That's your V what? Your V initial, your VI, 33.7, okay? And here was the tricky part, the common mistake that people made while I was helping them out, okay? And that is the speed limit is only 20.8 meters per second. Okay, so that's actually not your final speed. That's the tricky part. Okay, that's going to be our average speed because what it is you want to slow down enough so that by the time you go across the second strip, your final speed, your velocity average is less than the speed limit of 20.8 meters per second. And I know that's a really weird number. And in real life, speed limit's just like 20 miles an hour, 25 miles an hour. But what traffic engineers would do is they would look at what is the average speed of someone driving in your neighborhood. And if it's like way too high, like 39 miles an hour, they're going to put up the stop sign to slow you down, okay? Or like the speed bumps and all that there. Actually, you know what is really dangerous? Is coming into our school every morning, okay? Whoever designed our school did not think about how traffic flows. It's like the dumbest thing, right? 55th and Grand Street, but then you come in off the side, like by the dumpster. Welcome to Hinsdale Central. Come in by the dumpster and try not to get killed crossing the street there, right? So anyway, that's why then a traffic engineer, if they could collect data on how much people are speeding, that's why they finally added the crosswalk with the white strips and all that. But we might even need like speed bumps because some people drive crazy in the morning. Okay? Anyhow, don't be one of those people. So what I want to point out is the speed limit's 28.8 meters per second, and at the instant the car activates the first strip, you start to slow down. What's a fancy way to say slow down? You are accelerating. It'll be a positive or negative acceleration. This is common sense. It'll be what? Some kind of negative acceleration. You're decelerating. You're braking. Okay? And the question is, how much do you have to slow down so that your average speed, that's a hard one, is within the limit by the time the car crosses the second marker there. Okay? So common mistake was everyone called 20.8 meters per second their final velocity. So actually, Speaking of final velocity, that's what we have to find in order to solve this, because we don't know VF and we don't know time. Okay? Do we need to know time? We actually don't, right? We just have to find the acceleration. That's the problem. Okay? Put a star around that. Half the problem is knowing what the problem is. We want to find that acceleration. Okay? So notice in our nifty equations, you have to have at least 3 out of the 5, because each equation has 4 variables. We can't solve this until we find VF. So how can we find the final velocity if we know the initial velocity? Okay? If we know initial velocity and final velocity, how do you get the average of two numbers? Velocity average is simply equal to, how would I get the average of 100 miles an hour and 50 miles an hour? I would just add them up and what? Divide by 2, right? So your velocity average is just your VI plus your VF divided by 2. Okay? That's the equation we got to use. It's not like a formal equation, but it's a conceptual idea there. Okay? Man, I'm having coordination issues on a Wednesday morning. A little bit more caffeine. Tea. There you go. Do coffee, then tea. Flex fuel. There you go. Asian side. There you go. Just kidding. Anyhow, don't drink too much caffeine. Bad for you. Stains your teeth. Anyhow. VF plus VI over 2. So anyways, if the velocity average was 20.8 meters per second, in this case, my initial velocity was 33.7, and I want to find VF. Okay, how could I get my final speed so that my average speed is only 20.8 meters per second and I make the speed limit? All I do is multiply both sides by 2. So let's just get out the... So anyway, let's just plug and chug. I take my average speed, 20.8. I multiply that sucker by 2. And then to get VF by itself, I have to subtract 33.7 from both sides. Okay? A little bit of basic algebra. I get a final velocity of 7.9 meters per second. Okay? VF is 7.9 meters per second. So what does that mean? It means that in order to get my average speed down, because I was speeding like a crazy idiot in my neighborhood, I have to slow down to 7.9 meters per second to drop the average down to 20.8. Okay? Which in general, the lesson is you shouldn't speed in your neighborhood because, totally not cool if you hit a little kid running around there. Okay? In the front yard. Baby Lau number 3, my little guy. Danny's like 3.5 there. Little boys like to run into the street. I have no idea why. Like, duh, there's a car coming. Like, stop. Okay, anyhow. Now, it's trivial, okay? I want to know A. I know delta X is 103.7 meters. I know VI is 33.7. I know VF. So how do I know which nifty equation to pick? What's a little trick? It's what you don't know that helps you pick the equation. Isn't that cool? Okay, in real life, literally, you won't have to solve nerdy physics problems your whole life, but you will have to solve complicated problems. The world has complicated problems. Knowing how to think and break down a problem logically and systematically, that's a big part of what I'm trying to teach you, okay? It's not just getting a number. So anyway, I want to know A, I know VF, I know VI, I know delta X. What I don't know is time. So which one doesn't have time? There's only one equation. Nifty number 4. Woo! Life is good. Let's do it, okay? So equation number 4. And do I really want you to write it out? I do, okay? I do want you to write it out when you plug and chug into step 4. So in step 3, we write out the equation. VF squared equals VI squared plus 2A delta X. Why do I want you to do that? It helps you learn the equations, number 1. But number 2, it's so you don't make up your own equation, okay? It's helping some people after school yesterday and also this morning. And some people are doing like little lotto physics. You guys ever see the lottery machine where it spits out the numbers on ping pong balls? Okay, people are just like multiplying, dividing, and squaring and square rooting numbers randomly. Don't do that, okay? Let's make your life easy. So now we got our equation. We can just substitute right in and solve. What do I put in for VF? In this case, it's 7.9 squared. VI is 33.7 squared plus 2 times the rate of acceleration times my delta X, 103.7. Okay? And by the way, a nerdy traffic engineer, if anyone wants to go into civil engineering, they would actually program this into the little box that runs the 2 sensors as you drive across, right? That way you can get the data that you need to see if people are speeding. So anyhow, this is just basic algebra. We take 7.9, we square that sucker. To get 2A by itself, we got to subtract 33.7 squared from both sides. And when we do that, we get a negative 1,073 point whatever. Yeah? 0.28. And that's equal to 2 times the rate of acceleration times 103.7. So algebraically, we just got to divide both sides by 2 and 103.7. No biggie, right? Divided by 2, divided by 103.7 to cancel that all out, right? And so when we do all that, we get an acceleration of negative 5.175. Keep a couple decimals, okay? A equals, actually, let's put this in red. We got the final number. Yay! Ah! There we go. Switch colors on me. Thank you. Negative 5.175 meters per second squared. Okay? And why is it negative? Because the car is what? The car is slowing down. Okay? To recap, picture is really important to see what's going on. Not only do you have a car driving along between two pressure-activated strips on a speed trap, you're only given the initial velocity and the average velocity. That's the tricky part. So to get the average velocity, you have to use VI plus VF over 2 to get the final speed. Then when you divide out, you can get the acceleration, and then you get your final answer. Okay? That's the speed trap problem in a nutshell. Question? Okay. That was an excellent question. Why the average speed is 20.8 and why it's not the final speed. If you look at this, if the final speed was 20.8, let's just get out our calculators really quick. Sometimes just looking at the numbers helps. If your initial speed was 33.7, your final speed was 20.8. So if I add up those two numbers and divide by 2, your average speed would be 27.25, which is over the speed limit. So the trick is you actually had to slow down way more than the speed limit to get the average down to be within the speed limit. Okay? So all it is they give you the average speed in this case instead of the final speed. Okay? So this is a trickier type problem. This would be what we consider not a level 2 problem where